Hi everyone! In today's video we are going to look at the last part of chapter 7, which is types of variation. In this video you are going to learn to identify 3 types of variation: direct, inverse, and joint. After you know which type of variation you're working with, we're going to be finding the constant of variation, and then we're going to create a variation equation using the variables and the constant of variation for a given problem so that we can solve. Okay, so let's get into just what variation is first. When we look at variation, we're looking at a relationship between 2 variables, or maybe more. And there are 3 types of variations that we're going to look at. The first is called direct variation, and you're going to see it written in problems as one variable varies directly with another variable. And the formula that we're going to use is this one here. Y is equal to A times X. In this equation, X and Y are our variables, of course, and A is what is called a constant of variation, and A is not ever going to equal 0. We are going to have to figure out what A is in order to solve the problem. The second type of variation is called inverse variation. This is when Y varies inversely with X, meaning that whenever Y increases, X is going to decrease and vice versa. And because of that, we are going to have an inverse relationship. So one variable is going to be in the numerator on one side, and the other side of the equal sign, the variable is going to be in the denominator. When one goes up, the other goes down. A good example of these two are if we had say a bunch of cookies in class, and if I had a set number of cookies, so I have say 10 cookies. If I have 10 people, then everybody gets 1 cookie, but if we have 20 people, then the cookies get split in half and everyone only gets a half of a cookie. So the greater number of people that we have in the classroom, the less amount of cookie each person gets, because we have to break them into pieces. That's inverse variation. The last type of variation is joint variation, and you'll see that it looks like this, or sounds like this, when one variable varies jointly with 2 other variables, X and Z. This is a kind of direct variation, because you're going to have Y is equal to the constant of variation times the 2 variables being multiplied together. So we are going to be looking at multivariable variations, or multiple things that are changing in our equation when we look at joint variation. Okay, so let's hop into how to solve these problems and then look at these individually. Whenever we solve a variation problem, regardless of which of these 3 types it is, we first need to figure out which one of these formulas are we going to use. Then we need to substitute in the values that were given so that we can solve for A and find our constant of variation. And then we're going to write our formula as an equation with the A substituted in. And that's going to give us an equation where we can find other values, or solve the problem, if you will. Okay, so let's talk about direct variation first. Direct variation is a function that can be represented by this straight line that goes through the origin. We're going to say Y varies directly as X, and it, as I said, will pass through that point 0, 0. So if you look at these 2 examples here, you can see that our constant of variation is 3, and we have everything in the numerator. If you look at this other one, notice that the X is on the same side of the equation as the Y. If we wanted to get that to look a little bit more classically like this formula that we have been talking about, if you multiply by X on both sides to get rid of those, then you have Y is equal to 3X. And so it gives us that same direct variation relationship, even though it looks a little bit tricky. Okay, so let's at first just figure out which equations are direct variation. So if we look at this first one, 2x minus 3y is equal to 0. Let's solve it for y so that we can see what it looks like. So let's subtract 2x from both sides first. And then let's divide both sides by negative 3. So that gives us y is equal to 2x over 3, because a negative divided by a negative is a positive. And that's the same thing as 2 over 3 times x, right? And this, yes, is direct variation, where a is equal to 2/3. We have y varies directly as the constant of variation, 2 divided by 3, is being multiplied with our variable x. Okay, so let's look at this next one. We're again solving for y, so I'm going to subtract x from both sides, and that gives me negative x minus 5. This is not a constant of variation being multiplied with the x. It has this minus 5 on the end. So this one is no, it is not a direct variation relationship. You also could think about the graph for this one. The graph of this line passes through the y-axis at negative 5, which means, and if it's decreasing, it's going to look something like that. It doesn't go through the origin, and direct variation has to go through the origin. So that's a nice quick way you could test without having to do a lot of work if you wanted to. Okay, so the third option is y is equal to x divided by 5. So if I rewrote this as y is equal to 1 over 5 times x, so if I just pull that coefficient out front, I think it's a little easier to see in this one that yes, this one is direct variation, where the constant term a is 1/5. Okay, so let's try a problem now. The problem number 2 says, given that y varies directly as x, write a direct variation equation to find the missing value. If x is equal to 24 and y is equal to 64, find y when x is equal to 15. Okay, so step 1 is we need to find the equation. Now we know this is direct variation, so we know we're going to be working with y is equal to a times x. Now we are going to find our constant of variation using this information that we were given first. We have x and y, so we're going to plug both of those numbers in to our direct variation equation. Okay, so now I'm going to divide both sides by 24, and I get that a is equal to 8 over 3. So now I have my constant of variation. That's good, it's because now I can write the actual equation. I can use this formula but plug in that a. So I have y is equal to 8 divided by 3 times x, and that is my equation. That means that for any y value, or any x value for that matter, I can find the other. So I can find y when x is equal to 15 now, because all I have to do is plug in the 15 to the equation with my constant of variation that I just found. So I need to do 8/3 times 15. Well, 15 is divisible by 3. That is 5. And 8 times 5 is 40, which means that my answer, my y value, is 40 when x is 15. Okay, so let's talk about the second type of variation, inverse variation. Now remember, this is the one that's like with the cookies, and the more classmates we have, the less cookie each of us gets. You're going to see this one described as y varies inversely with x, and we are going to have an x down in the denominator of our formula. This is a rational function because it has the variable down in the denominator. So this is why this is in chapter 7. We're going to have a graph that is a hyperbola. Okay, so notice also that this blue value up here, that's our constant of variation. So we're going to have to find that k value just like we were finding the constant of variation in the previous problems too. So let's set this one up. The variables x and y vary inversely, and y is equal to 15 when x is equal to 1/3. Write an equation that relates x and y, then find y when x is equal to -10. Okay, so the first thing we need to do is write down our formula. Y is equal to a over x, and now we need to plug in the information that we know because we have our inverse formula written down. So I'm going to write 15 is equal to a divided by x, which is 1 divided by 3. So I'm going to keep change flip this first. A, because this is the same thing as a, is divided by 1/3. So if I keep change flip, I've got 15 is equal to 3a, and then when I divide by 3 on both sides, it gives me that a is equal to 5. Okay, so I have my constant of variation, which means I can write my equation now. My equation is y is equal to 5 divided by x. And now I can find any y value that I want. So I can find y when x is equal to negative 10 by plugging in a negative 10 to the equation. When I simplify that, I get that y is equal to negative 1/2, and so that is my answer for this inverse variation. Let's look at one that is a little bit more complex now. This problem says the number of songs that can be stored on an MP3 player varies inversely with the average size of the song. The MP3 player can store 2,500 songs when the average size of the song is 4 megabytes. So if you have really big song files, you can't store as many songs on your player, whereas if you have really small files, you can store a bunch of them. Makes common sense, right? So let's see, write an equation that gives the number n of songs that will fit onto the MP3 player as a function of the average song size. So we're trying to find here the number of songs. So that means that n, the number of songs, is going to go on one side of our equation, and then on the other side, because this is an inverse variation, we're going to have some constant number over the average song size, so we'll put an S there for a size. This is our formula that we're going to be using given these variables. So let's find the equation now. Let's see, we know that it can store 2,500 songs. That's what n is equal to. And that happens when each of the songs on average are 4 megabytes. So I've plugged in my number of songs and my size of songs from the information I've been given, and now I can find my constant of variation. Once I have my constant, I can plug it into the formula, and that will be my equation. So I'm going to multiply on both sides by 4, which means that a is equal to 10,000. I've got my constant now, so I can plug that in. N is equal to 10,000 divided by the size of the song. So this is my equation. All right, let's see what it wants us to do next, because it's not trying to ask us anything more than that for that problem. Create a table of values for the following size of songs. Okay, so when the average song size, this is the S value, is 2, that means how many songs? What's the number of songs? So if I know n is equal to 10,000 divided by the size, I can do 10,000 divided by 2. That's 5,000. So it means I'll be able to store 5,000 songs on my MP3 player. If I have an average size of 2.5, I need to do 10,000 divided by 2.5. That is 4,000. If I want 3 megabyte songs, I need to take my 10,000 and divide it by 3, which gives me, well, that's going to be approximately 3,333. There's a little bit of rounding that has to happen there. And then if I have 5 megabyte songs, then that's going to mean that I can have 2,000 songs on my MP3. So notice that as the size increases, the number of songs decreases. This is a really important concept for you to understand about inverse. With direct variation, as x goes up, y goes up too. As x goes down, y goes down too. With inverse variation, as one variable goes up, the other one goes down. They have a reverse or inverse relationship. And you can always check for inverse variation by asking yourself, does the data have the same constant of variation? Are we dividing the size into 10,000 every time? As long as that division is happening, then it's an inverse relationship. Okay, let's look at our last type of variation, joint variation. Joint variation is the variation that joins together direct and inverse variation. It occurs when a quantity varies directly with a product of two or more. I missaid that a moment ago. It doesn't have inverse within it. It just has multiple variables that are varying jointly. Okay, so the equation, as you can see up here, is going to have some variable z is equal to the constant of variation times multiple variables that are varying directly. So you could say, for example, z varies jointly with x and y in this first piece. You could say in the second one, p varies jointly with q, r, and s. So notice here you can have more than just two variables with a joint variation. They're all being multiplied together because we're looking at a product here. All right, so let's look at this first problem. The variable z varies jointly with x and y. That means I'm working with z is equal to ax, y. Also, z is equal to 60 when x is equal to -4 and y is equal to 5. So if I plug those values in, because I need to find my constant of variation first, I have 60 is equal to a times -4 times 5. I can find my constant now and then plug it back in, and that will give me my equation. So I've got 60 is equal to -20 times a. When I divide by -20 on both sides, that gives me a is equal to -3. So my equation is z is equal to -3xy. Okay, and now I can find any z that I need to if I know x and y, and I do over here, so I'm going to plug in these values. Z is equal to -3 times 7 times 2. That means z is equal to -42, because 3 times 2 is 6, so that's -6 times 7, which is -42. All right, the last thing that I'd like to do is a little bit of practice with this first step where you're figuring out the formula, because once you have the formula, it's just a matter of plugging in values, finding your constant, rewriting your equation, and then plugging in some new values and doing some substituting. The, I think, hardest part is figuring out what the formula looks like, because sometimes it's going to be a little different. So let's look at a few practice problems, and this time our directions say that we're going to use k as the non-zero constant. So where that a is in the notes, I'm going to use a k this time. All right, the first one says y varies jointly with x and z. So if this is a joint variation, that means I'm going to have y varying with a constant, or constant is going to be k, and then the product of our other variables, x and z. So y is equal to kxz. In the next one, it says y varies inversely, so we're going to have a fraction there, with the square of x. The square of x is x squared. So that's what is going to be varying inversely, which means this is going to be my denominator. So y is equal to, because it says y varies, because it's an inverse relationship, I'm going to have a fraction bar. When I have an inverse variation, my constant is in the numerator, and then my thing in the denominator is this x squared. Okay, let's try one more of these. R is inversely proportional, so I'm going to have R is equal to something. It's going to have a fraction bar in it because of that inverse relationship. So R is inversely proportional to S, which means the S is going to be down in the denominator, and directly proportional to the square of t. So the direct variation means I'm going to have multiplication up in the numerator. I'm going to have my constant term, and also up in the top, I'm going to have, as part of my product, the square of t, t squared. So that guy's going to go there. Okay, so for this one, this is inverse and also direct variation. So you can see I have one variable down in the denominator as the inverse part, and one variable up in the numerator as the direct variation part. For each problem that you look at, this is your first step. Figure out which formulas to use and what the equation is, so that then you can find the constant and write an equation specific to that problem. In this video, You have learned how to identify the three types of variation: inverse, direct, and joint. You've learned how to find the constant of variation once you've figured out your formula. And then you have created a variation equation using the variables and the constant of variation to then solve for other values. So I'd like for you to go ahead now and try the practice problems.